Have you ever really stopped to think about how you experience, well, anything? How does all the light and sound and everything else out there get turned into your own personal reality right inside your head? We're going to dive into that because what you might think is just a simple camera recording the world, oh, it's so much cooler and weirder than that. Okay, first things first. What do you see here? Just take a good look. Right now, it probably just looks like a bunch of random black and white splotches, right? But just relax your eyes. Let your brain chew on it for a second. See it yet?
That little puzzle you just solved, or are maybe still solving, is the perfect way to kick this off. It demonstrates the two incredible processes we're about to explore. The journey from those raw splotches of ink to seeing a dog, well, that is the journey from sensation to perception.
So here's how it all breaks down. Sensation is just the raw data coming in. Your eyes taking in those black and white spots. Think of it like a pile of raw ingredients. But perception, that's your brain playing master chef. It takes all those random ingredients and cooks them up into something you actually recognize. In this case, a Dalmatian sniffing the ground. The big takeaway here, you don't just see the world. Your brain actively builds the world you experience.
Now, our senses are absolutely incredible, but they do have their limits. So let's take a look at just how ridiculously sensitive you really are, and where that line is between something being there and you actually knowing it's there.
So scientists have a name for this limit. It's called the absolute threshold. And it's basically the faintest, weakest stimulus that you can possibly detect at least half the time it's presented. And you are not going to believe how low that threshold is for some of our senses.
Okay, look at this. 50 kilometers. What on earth could a human possibly sense from that far away? Any ideas? That's right. If conditions are perfect, a clear, dark night, your eyes are so sensitive, they can spot a single candle flame from 50 kilometers. That's about 30 miles away. I mean, that is just an incredible feat of biological engineering. All right, ready for another one? One drop. Just one. What do you think one single drop could do? Just one drop of perfume is all it takes to fill an entire 3-room apartment with enough scent molecules for your nose to pick it up. It's an amazing illustration of just how powerful our sense of smell really is. But wait a second, if our senses are that sensitive, why aren't we constantly overwhelmed? Well, the answer is something called sensory adaptation. You know this feeling. When you first jump into a cold pool, it feels like ice, right? But after a minute, you're fine. You got used to it. That's your senses adapting. It's the same reason you stop noticing the hum of your refrigerator or even the feeling of your own clothes. Your brain just tunes out the constant stuff so you can focus on what's new and important. So we've got all this sensory data coming in. But how does the brain actually organize it all into a world that feels stable and makes sense? Well, it turns out your brain has this kind of secret recipe book, a whole set of built-in rules it follows without you even thinking about it.
These rules are called perceptual constancies. For example, size constancy is why you know a person walking away from you isn't actually shrinking into a tiny doll. And shape constancy is why you know a coin is still a circle even when you look at it from the side and the image hitting your eye is actually an oval. These rules create stability. Without them, our world would feel like a chaotic, morphing mess all the time.
Your brain also uses another set of rules, the Gestalt principles, to group things together. Proximity means we group stuff that's close together. Similarity means we group stuff that looks alike. And hey, remember our Dalmatian friend? That was closure at work. Your brain literally filled in the missing lines between the splotches to create a whole dog out of a bunch of fragments.
All right, now that we know some of the rules, let's put it all into practice and focus on our most dominant sense, vision. We're going to do a couple of super quick experiments right now that'll show you just how much work your brain is doing behind the scenes.
First up, let's find your blind spot. Yep, you heard me. You have a spot in each of your eyes where you are completely 100% blind, and I'm going to show you how to find it. Go ahead and pause and try this along with me.
Okay, you ready? Here's what you do. Close your left eye. Now, with your right eye, stare only at the boy. Don't look at the pie, just focus on the boy. Now slowly move your head or the screen further away from you. Keep staring at the boy, and at a certain point, poof, the pie will completely vanish.
Well, what just happened there? Where did the pie go? It didn't actually disappear, so why couldn't you see it?
At that exact distance, the image of the pie landed perfectly on your optic disc. That's the spot where the optic nerve leaves the back of your eye. There are 0 rods or cones there, no light-detecting cells at all. But did you see a big black hole in your vision? Nope. Your brain just papered over it, filling in the gap with a surrounding white pattern. And it does this for you seamlessly every second of every day.
Pretty wild, right? Okay, for our second experiment, we're going to mess with your color vision. This one reveals a really fascinating secret about how we see color.
Okay, for this to work, you have to stare at the center dot of this flag for about 30 seconds. Seriously, don't move your eyes. Just lock your gaze right on that dot in the middle. Come on, keep staring. We're about halfway there. Don't look away. Almost done. 3, 2, 1, now. Quickly look over at a blank white wall or a white piece of paper. What do you see? You should see the flag in its proper red, white, and blue.
So what was that magic?
Well, this trick shows that your color vision works in pairs. Think of it like a bunch of little seesaws in your brain. You have one for red versus green and another for blue versus yellow. By staring at that weird green and yellow flag, you totally exhausted the green and yellow sides of those seesaws. When you looked away at a white surface, the fresh, rested red and blue sides rebounded, firing back and creating that ghostly afterimage of the real flag. It's an amazing peek at the machinery of sight.
So let's pull all this together. From seeing a Dalmatian that isn't really there, to filling in your own blind spot, to creating after images of colors, it all points to one mind-blowing conclusion. Your brain isn't a camera, it's an artist.
And this really gets to the absolute heart of it all. As the source material puts it perfectly, what we perceive is often based more on what goes on in our brains than what is in front of our eyes. Your reality isn't a recording. It's a constructive masterpiece, painted in real time by the artist in your head.
And that leaves us with one last big question to think about. If your brain is constantly selecting, organizing, and flat out inventing the reality you experience, what might it have left out? What did you fail to perceive today?